Hello, today we are going to continue exploring the logarithms. And so in last video, we talked about what logarithms are and we realized that it is the inverse of it's the inverse function of the exponential function. And so this is how a logarithm function works. If you have y equals a powered by x, an exponential function, then you put the exponent on the left side, and then you put the number a, which is the base in the exponent form, and you put that into the base again into the log function. You see where the a is, that's the base. So the base is always the base in either function, in either exponent or in logarithms, and y goes into the log function. It's easier if you're thinking like this. A log function the purpose is to find what the exponent is. Then you set the x as if y, and then you turn it to the left side. Okay, so this is how a log function works. Let's practice. So if we assume that there's an equation 8 equals 2 powered by x, you change the log function. What do? We're going to find out what the x is. So you put x on the left side, and then x is equal to log, what's the base? The base was 2. In the exponential function 2 powered by x, the base was 2. So here in the log function, the base is 2 again. And you insert the 8 straight into the log function. X equals log base 2, 8, which is equal to 3. These are the warm-ups. Let's try solve this problem ahead of me, and then we'll catch up later on. Are you done? Then let's check what the answers are. The answers are, in the function y equals 5 powered by x, if you apply logarithms, it is x equals log base 5y. In the next function, it's the same process, it's just the numbers are different. X equals log base 6 to the y. Now, in the next one, there's a bit of trick. It's an easy trick though. Y equals 5 powered by 2x. What do? You first form the exponent, you turn the exponent on the left side, you shift it there. The base always is the base, log base 5, and y, you insert the y over there. And all you gotta do here is divide all the function by 2. So x equals 1/2 log base 5y. This is how you solve a simple log. Let's move on to the second warm-up. Find the value of the following logarithms. So in the previous warm-up, we had to apply a logarithm. This time we're going to do the reverse version. Again, try solving by yourselves, and then we'll be checking the answers. I believe you have solved and you got your answers. Let's check it out. So the first question, log base 2 to the third 2, you can swift it as log base 2 powered by 6. Whenever you can do this, it's much more easier and it simplifies the equation, and it will be better for you to solve the problem. 2 powered by what is 2 powered by 6? Obviously 6. The answer is 6. The next one is kind of tricky. Log base 5, 1/5 equals -1. Why does this happen? So I wrote underneath as a hint, think 1/5 as 5 powered by -1. If you do that, then you know what the answer would be. Your base is 5 powered by something, powered by something equals 1/5. What would that be? -1. So the answer is -1. Log base, just 100, log 100. There's no base. Why does this happen? There's just log 10. There's just log and 100. What's the base? In this kind of situations, we assume that the base is 10. These are called as common logarithms. So whenever you don't see a base, it's always just 10. Log base 10 to the 100, which equals 2. And there's another logarithm that's similar to the common logarithm that it skips. It doesn't show the base. And that is natural logarithm. Natural logarithm is any log function with a base e. E is a Euler's number. It's named after a famous mathematician called Euler. And e is equal to, it's a mathematical constant, 2.71828, and it never ends. It keeps continuing. And so log base e to the x, we read it as ln x. It's something special. And if you see this log function, you just assume it's just another log function with a base e. So now let's move on to the core, the most important parts. One of the most important parts when studying logarithms, the properties of logarithms. And there's a warning here. All the rules I'm about to present are under the assumption that if we have a log function log base a to the b, firstly, a is always bigger than 0, and secondly, a is not equal to 1. Let's go. So the first rule is that log base a to the 1 is always 0. You put 10,000, 100 billion, 5,555, it's always going to be 0. This is because a powered by 0, any number powered by 0 is equal to 1. The second rule, log base a to the a is equal to 1. This is because obviously anything powered by 1 is itself. Thirdly, log base a to the a powered by x is equal to x. This is obvious because, as you can see, you just reverse the function into an exponential version, then you get a powered by x equals a powered by x. Simple, good, until now. And now there's a bit kind of confusing one, but it's not that confusing at all if you understand the logic. A powered by a log base a to the x is equal to x. Now, before I explain, try mathematically proving yourself why this rule makes sense. Have you proved it? Well, let's see and if we are on the same track. So let's say we apply logarithm to this equation. Then you move, the exponent is log base a to the x, so you move down the left side, that's good. And then, what is the base? The base is a. So log base a to the x is equal to log base a to the x. Do you see how it works? It's kind of confusing, but if you keep up the trail, it's kind of easy to follow up. Exponent on the left side and the base as the base, and the final value in the log function, log base a to the x is equal to log base a to the x. That's it for today, and thank you for watching.